Hello everyone. In this video, I'm going to be talking about abstract classes in Python. Abstract classes basically serve as blueprints for other classes. They allow you to create abstract methods, which are methods that have declarations but do not have code defined under them. Usually in Python, you can actually define some code under abstract methods, but you normally would leave a pass statement or a blank return. You can also leave a docstring, which is what I prefer doing. This works because a docstring is actual code in Python. It's technically a string literal that Python will automatically store in the dunder attribute for the docstring. And as a side effect of placing a docstring under the method, that method will implicitly return none by default. Now, as soon as a single abstract method is declared under a class, that class becomes an abstract class. And once a class becomes abstract, you are not allowed to create objects with that class. Python will throw an error. You can only use it as a parent class for other classes to inherit from. And those subclasses must include any abstract methods from the parent class and their own class definitions. And that is the purpose of abstract methods, to enforce their inclusion in classes that inherit from abstract classes. In order for us to use abstract classes, we have to know how to use inheritance. So let's start with a refresher on basic inheritance. I've got two classes here, a parent class and a child class. A child class is a subclass of parent, as indicated by this line here. Whenever we inherit from a class, we specify the parent class in a set of parentheses after the subclass name. As a result, the subclass will inherit any potential attributes and functions that its parent class may have defined. So this child class will have access to the arg1 attribute here, and it will also have access to the function1 method right here. And in order to gain access to all of the things that are inside the parent class, we have to use this line here, where we call super, followed by the init magic method, which we then pass in any potential arguments required by the parent class. In this case, we're taking arg1 and feeding that in back up to the parent class. So in this code down here, we're creating a parent object and a child object. The parent object just has a single string arg1 that's going to get stored into the arg1 up here. And then we call the func1 method from the parent object. And then when we create our child object, we're giving it two arguments, both strings still, but one is arg1 and the other is arg2. Arg2 will be stored in an attribute that's only accessible by the child class. Arg1 is going to get fed through super back to the parent class, so it can be stored in the arg1 attribute here. And then I call the func1 method from the child object, which will result in the func1 method defined under the parent class to be called. I'm going to add something on to this as well. So I'm going to print out p.arg1 here, and then down here I'm going to print out c.arg1 followed by c.arg2. So when I run this, when we call func1, we print out that message, but it says the parent object called func1. Then we print out our variable here. And then for this one, this message here will state that the child object called it instead, and then it prints out the two variables that it has here. Now let's look at this parent-child example again, but this time we're going to implement an abstract class. So to implement abstraction, we have to import two items from the built-in ABC module, and that is ABC, all caps, and the abstract method. Abstract method is a decorator that we would use to decorate methods inside the class that's going to be abstract. So here we have the parent class, and it inherits from ABC, which stands for abstract base class. So this is going to be our abstract class. We define our init function for it, we specify our parameter and our attribute for the parent class, and then we provide a declaration for the func1 method, but instead of giving it actual code, I just have this docstring here. And right above it, I decorate it with the abstract method decorator. And then down here, I define our child class, and it inherits from parent. It provides its own init function as well, and we specify the parameters arg1 and arg2, and like before, it will pass arg1 through super to the parent class, and then we define our own version of the func1 method inside the child class, and it simply prints out the message abstract method. And then down here, we create the child object with these two parameters. So first, I want to show you what happens if we didn't define the func1 method. So I'm going to comment these out. And when I execute it, we get this error. It says it can't instantiate the child object with abstract method func1. And this is because through inheritance, we inherited the abstract method. So as far as Python's concerned, the child class does have a func1 method like its parent because it inherited the parent's method. but it sees it as an abstract method under child as well. So it won't let us create a child object because the child class is considered abstract as well. So whenever we inherit from an abstract class that has abstract methods, we had to make sure we implement those methods. So I've uncommented func1 now, and when I execute the code again, we don't get any errors. We don't get any output because I don't have output printing out right now, but we don't get any errors as well. And the no output was actually a mistake on my part. I forgot to have it print out stuff. So let's have it call func1, execute the code again, and it calls the abstract method that we defined under the child object. So why use abstraction? I have two examples for this, one that's mostly conceptual and the other one that's actually applicable. And the reason I'm using a concept example in this video, even though I try to avoid it, is because in this case, I actually think it's very helpful for abstraction at the very least. And the example I'm going to use is one that I was actually taught when I was in college, learning how to program. And so we're going to do that example first. And this example is basically to demonstrate how we provide specification to abstraction, which can be important in programming in general, not just in Python. Basically, we want to create classes that can be inherited from, but can never create an object of that type directly. And as you've seen in the previous example, that's one of the things that abstraction does. An abstract class prevents us from actually creating objects from that class. And the example that I'm going to use is pets. The definition of a pet is a domesticated animal that is kept for companionship. And while we may sometimes just refer to them as our pets, a lot of the times we refer to them as what they are more specifically: dogs, cats, birds, fish, and so on. There is not really a thing specifically called a pet. Therefore, in a sense, a pet doesn't exist, but the different types of pets do exist. So in programming, we would not create pet objects, but we would create objects for those specific types of pets: dogs, cats, and whatever else, to inherit from that pet class. And part of where abstraction in programming comes in here is when we define abstract methods, because the methods that we define as abstract are methods that we're stating that anything that inherits from this class needs to be implemented in those subclasses. So for a pet parent class that's abstract, we can define two abstract methods, speak and move, because all pets have a way of communicating and all pets have a way of moving. Then when we define the subclasses of pets, whether it's for dogs, cats, birds, rabbits and snakes, and whatever else, we have to provide an implementation for those abstract methods in each of these subclasses that will define specifically what each of those pet subclasses will do for those two methods. Now here's a more applicable real-world example for using abstraction. You're developing an API for other developers to use. In this case, we are using abstraction to require the implementation of certain methods from abstract classes in order to allow custom classes to work with the API being utilized. Oftentimes, developers will need to create their own custom classes that inherit from API they are using. Sometimes that is the only way for them to create what they specifically need for their program. But sometimes an API requires classes to have certain methods implemented to work. So to ensure custom classes work with the API, we can use abstraction to enforce the inclusion of these methods in these custom classes. For this example, I've created a very simple API for a plugin manager. So there are two parts to this example that I've divided up using comments. The first part is our API code, as you see here. And then down here, we have our code that interacts with the API code. We're using abstraction. We've got ABC and abstract method imported and ready to be used. And then we have our first class, plugin manager. Now, plugin manager is not the abstract class. This is just a regular class that acts as an engine to load and run our plugins. So we got a method to load our plugins in, and we got the one to run our plugins. And in here, it's going to try to verify them first. And if for any reason the plugin that's loaded in returns false when we call the verify function, then it will say, oh, it couldn't be verified, and then it skips over it. Otherwise, it will then run the plugin. Now here's our actual abstract class in our API, the plugin class. It inherits from ABC. It just takes in a name, and it's got two abstract methods, verify and run. These are the two methods that we have to ensure any subclass of plugin implements. Because if we try to use a plugin in our plugin manager here, and it tried to call those functions and they don't exist, then our program would crash with an error. So we make these abstract to ensure that if anyone inherits from this plugin, it will have those two functions. Now we have our code that's implementing this API. So we've got two subclasses here, test plugin and pilot ID plugin. Now test plugin is just kind of like a default this is definitely going to work plugin. There's no reason that this should fail for any reason. So it just prints out a message and there's no real meat to it. It's just a test to make sure the plugin manager works sort of deal. The Pilot ID plugin though, it actually has some functionality to it. The first thing it's going to do is it's going to check to make sure that the name attribute, which is defined up here, is not blank. If it's blank, it returns false, in which case the plugin manager here will say, oh, we couldn't verify it, so I'm not going to run it. As long as it's not blank, it will say it's verified that the name is valid, and then it will return true, so in which case the plugin manager will move on to this function here, run, where it randomly generates a 6-digit number to act as the ID number for the pilot name, and then it will print out that message here. And then down here, we create our plugin manager, we create the test plugin and immediately load it into the manager, and then we create 3 Pilot ID plugin objects and load those into the manager as well with 3 different entries, Crozo, Blank, and Lilith. And obviously the blank one is going to return an error. Then we call the plugin manager's run method in order to execute all these plugins. So when I run this, the test plugin of course ran just fine. Then we ran the first Pilot ID plugin instance with the name Crozo, and it generated this ID number for him. The second instance of the Pilot ID plugin failed because we gave it a blank entry. And then the third instance, where we provided the name Lilith, it generated another ID number. So that's a very basic, but very real world, very applicable example of how you could use abstraction in actual code. And it doesn't matter how deep the inheritance goes for these subclasses. As mentioned in the beginning of the video for the second example, if you don't provide an implementation for an abstract method inside a subclass, then that subclass will be considered abstract as well. That pattern will continue on for every subclass going down the inheritance line that does not provide an implementation for that abstract method. And I've got a basic example to show that. So we've got a base class ship that is abstract and has the abstract method connect to station. Then we have 2 subclasses, small ship and large ship, that inherit from ship. They don't provide any further implementation. They're basically taking everything from the ship class. And then below those 2, we have fighter and carrier. Fighter inherits from small ship and provides an implementation for connect to station. Carrier inherits from large ship, but it continues to not provide an implementation for connect to station. So when we execute the code down here, fighter will be created, and we will get this message when we call the connect to station method. However, carrier will cause the program to crash with an error because we are trying to create an object from a class that is still considered abstract. So when I run this, so we get the message for the fighter, getting landing clearance and landing in docking bay. So that was successfully created and it's successfully connected to the station. For carrier, however, we get the error that it can't create an object from it because it's an abstract class. So no matter how far down the inheritance goes, until you provide an implementation for the abstract method, the subclass will continue to be considered abstract. And that's about it for abstract classes in Python. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.